Hi everyone, today we are going to discuss Tutorial 1.1 Atoms and Molecule. Let's get started with question number 1. Question 1a. Define the terms proton number. Proton number can be defined as the number of protons in the nucleus of an atom. Next, define the terms nuclear number. Nuclear number can be defined as the number of protons and neutrons in the nucleus of an atom. The last one is isotope. Isotopes are the two or more atoms of the same element that having the same number of protons but different number of neutrons. Remember that students must memorize all the definitions of the terms. Now let's continue with question 1b. The questions: write the isotope notation for each of the following species. Remember that in writing the isotopic notations, the X will symbolize of the element, the A will symbolize the nuclear number, Z symbolize the proton number, and C for the charge of the ion. In the way to write the isotopic notation for the silicon-28 with 14 proton number, 14 neutron number, and 14 electron number, the isotopic notation for this species can be written like this. As the proton number of the silicon is equal to the number of the electrons, this makes the silicon with zero charge. For the chlorine-37, it has 17 proton, 20 neutrons, and 18 electrons. Thus, the isotopic notation for the chlorine can be written like this. As the number of proton of the chlorine is 17 and the electron with 18, thus it makes the chlorine atom have -1 charge. For the sodium-23, it has 11 proton, 12 neutrons, and 10 electrons. Thus, it can be symbolized as like this. Since the proton number is 11 for the sodium and 10 electrons, thus the extra proton number gives 1 positive charge to the sodium. Now, let's continue with question number 2. 2a. Define the terms relative atomic mass. Relative atomic mass can be defined as a mass of an atom of an element compared to 1/12 mass of carbon-12 atom with mass 12 grams. The next term is relative molecular mass. Relative molecular mass can be defined as the mass of one molecule of a compound compared to 1/12 mass of one carbon-12 atom. Make sure that you can differentiate between atoms and molecule. Now, let's continue with question 2b. If an atom of X is twice as heavy as one carbon-12 atom, calculate the relative atomic mass of the X. As the mass of one carbon atom is equals to 12.00 U, thus, if the X is twice heavier than the carbon atom, thus the relative atomic mass of X can be calculated as 2 times 12 by compared with 1/12 of carbon-12 atoms. Thus, the relative atomic mass of the X is equals to 24.00. Now, let's continue with question number 3. The following is the mass spectrum of zirconium. Calculate the average atomic mass of zirconium. From the given diagram, we can analyze the value of percent intensity of the isotopes and the mass of the isotopes. To determine the average atomic mass, we can use the formula of Ki. In this formula, the Q represents the abundance of the isotopes and M represents the mass of isotopes. Now, let's calculate the average atomic mass of the zirconium. By using the formula of Ki, substituting the value into the formula will obtain the average atomic mass of the zirconium that equals to 91.27 U. Now let's continue with question number 4. Iron consists of 5.82% of ferrum 54, 91.66% of ferrum 56, 2.19% of ferrum 57, and 0.33% of ferrum 58. The isotopic masses of these four isotopes are given 53.9396 U, 559394 U, 569354 U, and 57.9333 U. Calculate the relative atomic mass of the ion. To determine the relative atomic mass from the isotopic mass given, we can use the formula of average atomic masses, which is Ki. Then, from the average atomic mass obtained, we can compare the value with the carbon-12 atoms to get the relative value. Now, let's calculate the relative atomic mass for this ion. Using the formula of Ki, the average atomic mass of ferrum can be calculated by substituting all the isotopic masses and the abundance into the formula. Thus, it will obtain the average atomic mass of ferrum with 55.85 U. By comparing the average atomic mass of ferrum with mass of carbon-12 atom, thus it will obtain the relative atomic mass of ferrum with 55.85. Remember that the relative value is always without unit. To determine the relative atomic mass of a ferrum, we also have an alternative answer. We also can simplify the calculation step by using directly the Ki formula in the calculations. By substituting all the value in the Ki formula, thus it will obtain the value of the relative atomic mass with 55.85, but the answer must be without unit. Therefore, the 55.85 can be said as the relative value. Now, let's continue with question number 5. The element magnesium consists of three isotopes, which are magnesium-24, magnesium-25, and magnesium-26. The relative atomic mass of the magnesium is given 24.3. With a given relative atomic mass of the magnesium, that shows the value of the most abundant isotope. Thus, to answer question A, which is the most abundant isotope of magnesium, the answer is definitely magnesium 24. Thus, state the number of protons and the number of neutrons of the isotopes. Since magnesium 24 is the most abundant, thus the number of protons of this element must be 12. And the number of neutrons is also equals to 12. Remember that to determine the proton and the neutron number, we can use the formula of nucleon number that equals to the total number of protons and the neutrons. Now, let's continue with question number 6. Chlorine isotopes occur naturally as chlorine-35 and chlorine-37. The abundance ratio of these two isotopes is equals to 3.1 to 7. Based on the scale of carbon-12, the relative atomic mass of chlorine-35 and chlorine-37 are given 34.9689 and 36.9659 respectively. Calculate the relative atomic mass of the chlorine. Remember that in a way to determine the relative atomic mass, we can simplify the calculation steps by using Kincke equations. Now, let's calculate the relative atomic mass for the chlorine. Using the Kincke equations, by substituting all the value of the abundance and the isotopic mass, thus it will obtain the relative value of 35.45. Remember that relative value must be without any unit. This is our last questions. Question number 7. The isotopes of argentum occur naturally as argentum-107 and argentum-109 with their relative isotopic masses of 106.906 and 108.868 respectively. So if the average atomic mass of the argentum is given 107.868, what would be the percentage abundance of these two isotopes? To solve this problem, we can use an assumption method in the way to determine the percentage abundance of each isotopes. Now, let's get started by making an assumption. Let's assume that the percent abundance of argentum-107 is equals to X and the percent abundance of argentum-109 is equals to 100 minus X. In a way to determine the average atomic mass of argentum, we can use the formula of Kincke. By substituting the value into the formula, thus it will obtain the value of X that equals to 50.97%. The value of X is equivalent to the percent abundance of argentum-107. Thus, the percent abundance of argentum-107, which is equal to X, must be equals to 50.97%. And the percent abundance of argentum-109, that equals to 100 minus X, they are also equals to 49.03%.